Whenever you're ready to dive on it, I'd love to hear about what you'd be thinking about first. Mm-hmm. Question. What did X and Y represent there? Hmm. Mm-hmm. I'm listening. Mm-hmm. And you get an intersection at. So then, the next question is, would you round up or down from there? That is incorrect. So 182.1 jazz is the maximum number of large candles that you can buy under your budget. If you go up to 183 candles, then you have gone over budget. In general, if you need to round a maximum, you will always round maximums down. And if you need to round a minimum, you will always round minimums up. For much the same reason. 182. 182 is the largest integer that's smaller than 182.17 or whatever. 182.09. Excuse me. You do need at least 200 total candles. If you buy 182 candles, I believe you can buy 18 of the small candles. Can you see how in the shaded region 182, 18 should be in there, I believe? Or depending on, sorry, I blanked out on that. It might be the other way around, but I think I said it in the right order. For Mhm. Yes. They can theoretically ask you a question like this that is really evil, but I've never seen the SAT do it. Would you like to see an example of what this very evil variant might look like? It would look something like this. So here, let's say that this intersection has a y coordinate, has an x coordinate. No, I've drawn out the graph poorly. Give me a moment. Let's say that this has an intersection somewhere over here, and this intersection is, say, 20.5 comma 19.7 or whatever the hell. But if you need to find an integer amount of both objects, it's possible that the first area that's an integer is actually somewhere that's very far away from both of these, if the line is sufficiently diagonal and narrow. I've never seen the SAT do something like this because it makes the question unreasonably difficult. Yeah, the solution is only the values that are between these two lines. And if you can only buy an integer value of each amount, then that means that you need an integer value of each amount. So even if the theoretical maximum was like 205, 19.7, it's possible that the maximum amounts could be like 15, 15. But it would be really difficult and really obnoxious to set up a word problem that did that. And it would be really cruel as a word problem. It'd be very challenging to set up, but theoretically possible. Excuse me. Okay. The big takeaway from this one is definitely the idea of if you're looking for maximum, you round down, minimum, you round up. Very happy we got a chance to talk about that. I'd love to hear about your process for question 15. Lovely. Hmm. It would indeed be 20. And I notice you didn't use the Pythagorean theorem there. You instead used yes. Double checking. You clearly know this iteration of the 45, 45, 90. Do you know the other iteration? Like, what if the hypotenuse was just 20? Could you tell me what the side length would be then? Yes. Perfect. Very happy to hear that. I found the one that shows up in this question is the one that shows up in the formula set, but I think the one with an integer hypotenuse actually comes up a little more frequently. So I'm happy that you're proficient with both. Oh, clearly that was too much talking. Bodes poorly for this 7-hour workday. I wish that that was an option that I got to choose. But I have enough students that rescheduling is not very reasonable. And I do not want to leave my students in the lurch without the assistance they're trying to get their hands on. So mostly I'm just going to suffer my way through today and try my best. Excuse me. All right, tell me what you know about 16. 16 is, of course, a question we can get right every time via graphing it, but I'd love to know what you know about circles of your own accord. Mm-hmm. Mm-hmm. That is correct. Double checking. Can you tell me exactly where the center of the circle is for C? Perfect. I wanted to make sure that you weren't going to say 4 comma negative 9. Okay. There's a very cool way in which that's actually connected to every function transformation and every other graph formula. But if you've got it down, we probably don't need to elaborate on it. Okay. For question 18, what would you expect that you should do to solve it? Mm-hmm. How could you simplify that? Got it. I was concerned by thinking you were saying that you could cancel something out of top and bottom. We'll talk about the situations where you can and cannot do that in just one moment, but let's polish off this question first. That is absolutely correct. Now, you said that you can only do so in multiplication. A healthy way to think about factoring is that if you're uncertain of when it works, you only should cancel things out when it's in fully factored form. For instance, for this expression that I've circled, we could cancel a y out of the top and bottom, as well as an x minus 8, right? We shouldn't do that for this question, for what it's worth. That would be a bad choice. Because the final answer doesn't do that. But let's take a look at this final answer. Can you see how every single term in the top and bottom includes a y in it? In that scenario, you can actually cancel a y out of every term in the top and bottom. Hmm? Yes. Because in the first step, there is a y in in both the top and bottom. Now, this question is a little bit awkward in that normally when simplifying, we want to make sure to do that early on, and this question wants us to never do it at all, which is a little bit gross. Like, it's reasonable to not eliminate the x minus 8 from the top and bottom in the right equation, because we need to keep that around to combine terms. But usually we should be eliminating a y from both top and bottom. In order to simplify more fully. I suppose the reason that we're not allowed to do this is because they've not written that y does not equal 0, and 0 divided by 0 is undefined. However, they should have written that y does not equal 0, because otherwise this expression may be undefined. You can't cancel them if y equals 0, because 0 over 0 is undefined, and 1 over 1 is not undefined. If I can show off the difference between two graphs very briefly. This graph right here looks like a linear function, but it has a hole at 0, 0. It's undefined at that point. If we canceled an x out of top and bottom, it would not have a hole at that point. So that's why, if a variable can equal 0, technically speaking, you can't just cancel it out, because there is an actual difference in the function that that's expressing. I don't expect that to be a major issue on the SAT, though. I think that this one is just sort of poorly formed, where the SAT will usually not ask you to put something in that's not fully simplified. Excuse me. What should we do for question 20? Our solving for a variable problem. No, wait, 19? This is solving for a variable. We're not going to look for the greatest common denominator. They're asking us to isolate Q. Can you see how Q doesn't show up in any of the answer choices? Usually there's exactly one problem per test like this, but it does show up on every single test, so we do want to be on the lookout for it. Can I suggest bringing everything else to the right side instead, so that you don't have to deal with negatives? Then you could just choose to write 20 over Q on the left and everything else on the right. It's convenient to not make the thing that you're looking for a negative, just because that means you've got one fewer step to take down the line. Well, I mean, you're going to have to move both Q and P, or you're going to have to move both R and S. It's the same amount of work either way. Moving Q actually results in one more step, because then you have to multiply both sides by -1. You are correct. No. 1 over P plus 1 over R plus 1 over S. It is not 1 over P plus R plus S. I'm going to pause here for a moment. So you took a step that was valid, but it sounds like you didn't have a perfect understanding of it. So I'm going to suggest a heuristic for you. Before you do things with multiplying and dividing fractions, you'll usually want to combine both sides into a single fraction first. Yeah, and you'll have to have a common denominator to do that, right? Uh, did I hear 20 PRS? Shouldn't. Yes. Aren't those all divided by PRS now? Shouldn't you have multiplied this first term by RS over RS? Yes. Well, now you can turn it all into one fraction, right? Because they no longer have different denominators. You just did that thing to make them all have the same denominator. You multiplied this by RS over RS, so it's 20 RS divided by PRS, 20 PS divided by PRS, 20 PR divided by PRS. The whole point of what you just did was to make sure that they have the same denominator, wasn't it? You combine them into a single fraction that looks like this. There's no like terms. The important part is that we've made it all one fraction. That was our big goal because we noticed that when you eliminated 20 from both sides, your brain was skipping to 1 over q equals 1 over p plus r plus s. The big upside of this method is it is easier to avoid conceptual errors like that. Yeah. Hmm. Yes. Let's see. Do I remember what math class you're taking next year? I think that's approximately on the AP Calc level. Um, the reason that I bring that up is because getting good at fractions like this is very, very helpful for calculus. Calculus does a lot of fractions and a lot of things with variables in fractions. For instance, let's see, have you learned about derivatives yet? My guess is probably no. So, derivatives are lovely because the first time you learn about derivatives, they give you this formula. Excuse me. And this is a sort of nasty formula. You might notice that this is the limit as h approaches 0, right? And to evaluate that limit, we plug in h equals 0, but we can't do that initially because then we'd be dividing by 0. So you have to simplify your expression to cancel h out of the denominator, or otherwise make it no longer a problem and then plug in h. And you spend a while learning how to take derivatives this way, and then they just show you a bunch of way easier ways to take them afterwards. This is the definition of the derivative, and it's what mathematicians used for a long time before they figured out the rules for the more specific ways to take derivatives. But those more specific rules are pretty easy. Like, you want to know what the derivative of x cubed is? Uh, sure. The derivative of a graph is the slope of that graph at every point. So it's another function that tells you what the slope of the original graph is at any given point. What do you mean by that? It's a cubic. Sure. And that doesn't have a constant slope, right? It has a different slope at every x coordinate. The derivative lets you calculate what that slope is at any given x coordinate. And for just normal powers like this, we use something called the power rule. We reduce the power, we first pull that power down out in front. So the 3 goes in front of it, and then we reduce the power by 1. That's it. That's the derivative. It's just 3x squared. And with this derivative, we could say, gosh, I really wish I knew the slope of our original graph when x is 3. Well, we can just plug 3 in over here and figure out that the slope of x cubed at an x coordinate of 3 is 27. At that particular point, it would not be equal if we plugged in a different value. For instance, if we plugged in 2, then we would be getting a slope of 12 at 2 comma 4, right? Now, you did bring up a very interesting idea. Did you know that there is exactly one function where the y-coordinate is exactly equal to its slopes at all points? Have you ever wondered why e is such an important number? Sure, but like pi is innately related to circles, right? Well, then why is e so core to things? Why is it so inherently important? Well, it's because e to the x power has a derivative of e to the x power. Its y-coordinate is always equal to its slope. Exactly. Some wild stuff, huh? Um, the power rule only works when you have x being raised to some number power. It doesn't work when you have a constant being raised to the x power. We have to use a different rule for that one. If I remember correctly, the rule is specifically that you wind up with, if you have a to the x power, I believe the derivative is a to the x times the natural log of a, and the natural log of e is 1, so that just goes away. Anyways, this is not super useful for the SAT, although it can sometimes come up. Calculus is really, really powerful stuff. It lets us learn a lot of things about graphs. Mhm. Logarithms are not directly on the SAT, no. You can theoretically find a way to use them. I have not seen a question do this, but exponential growth questions are on the SAT, right? I'd like you to consider a situation like this. If we're solving this situation by hand, this is an exponential growth equation, but to find x we would have to use logarithms. For instance, if we took the natural log of both sides, a very important property of logarithms is that you'd be able to take this x and pull it down in front. Then we could divide both sides by the natural log of 2 to get that x is the natural log of 3 divided by the natural log of 2, which is an expression that we could plug into our calculator. Now, this is something that could theoretically be relevant on the SAT, but I don't expect it to be. I've never seen a problem dealing with it, even though exponential functions do show up, and I suspect that they are intentionally excluding this sort of math. Ow. That was painful. Do you know anyone who's very good at amputating throats? That's really unfortunate. If you did, I'd be very interested in their services right now. Got it. Yeah, you can just ask around a little bit for me. If you ever find someone who's very good at just like, taking a cleaver over there to the throat, very helpful right now. Also, if you know any throat donors, that would also be very convenient. All right, but I digress. I think you told me that you'd also polished off Blue Book 4, yeah? Did you want to review that test as well today, or is there something else you wanted to check in on? Sure. Do you mind if I get a list of the questions that you got wrong from Blue Book 4? Mhm. Got it, got it. Looks like it graded you pretty aggressively on that front. Two of them dropped us 20 points. Two questions dropped us 10 points, two dropped us 20 points. There might be internal math that's mocking that up. Like maybe questions internally drop, maybe these all internally dropped us 15 points, right? I don't know enough about the specifics to be able to speculate on that. No one does anymore. They used to tell us. They don't anymore. Mhm. Fascinating. That scoring is more forgiving than we usually see. Where the math module has fewer questions, so it more frequently drops us 20 points for getting a question wrong. My belief is that means that the questions you got wrong on the math side of things are all pretty tough. Yeah. Do you want to start on the reading side of things today, or do you want to keep working on math today? Sure. Looks like we do have a words in context question incorrect. First, can I check in on your vocab for this question? Is that a word that you're not as familiar with? Do you know the other three? Hearing it in a sentence is very important. I agree with your use there. They contrived a solution might be something that we'd say even more frequently. They contrived a solution to John's sleepiness. Yeah. Yeah, I don't know if you know that one. That one's pretty tough. Uh, what about regret? Do you think you know that word? Yeah. Clearly, you got the definitions of these down. So C and D you have on lock. B you can use in a sentence, and you've come up with a working definition. A you don't feel comfortable enough to use in a sentence, right? From here, we're going to try and look at the passage to figure out what sort of words should go in the blank, and as always, the entire passage is relevant. Excuse me. Um, was that claiming? No, I mean, was contriving claiming when you used it in your sentence. We contrived a solution for John's sleepiness. I thought you said that meant created. So it sounds to me like you're certainly eliminating C and D. Is this a question where you'd want to bet on contrived, or one where you'd like to bet on the word that you don't know? I think that this is a question where you might talk yourself into B, but with what I have heard of your knowledge of these words, this is a question where you should be selecting A, where when you use contrived in a sentence, it was not being used in this way at all. Now, I do also want to note that there is a connotation to contrived that you don't know. Contrived often conflates some element of deceit to it. Yeah. You could say something like, I contrived a way to steal the answers to the September 2025 SAT because I would be doing that via trickery. But you probably would not use it to say, I contrived a way to fix cancer via being a good person. I was going to try and give an example like via asking for donations with like very cute pictures of puppies, but that's something that could be theoretically contrivance. You're doing something tricky in order to make someone do what you want. Yeah. Contrived isn't necessarily bad, but it's fairly frequently bad. Ow. Oh my gosh. Okay. To surmise something is to assume it. And you might notice the word assume coming up later in the passage as well. There's intended to be a direct connection between those two. Claimed wasn't a perfect read on the passage, but it was very good. It was certainly good enough to get this passage right. And claimed makes a lot of sense here. Okay. Oh my god, I am fading fast. I've gotten through my first almost 3 hours with some energy. Let's see if I can get through the remaining 4 hours of classes. I've got 4 hours after this, yeah. Uh, they're not continuous hours, which is part good and part bad. It's part good because I'll have a break for dinner. It's part bad because my workday is going to end at 11:30 in Eastern Time. Yeah. That's only 8:30 my time, but it is still pretty late for someone who's gotten as little sleep as me. All right. Oh my god, ow. Where was I? Right. Before we moved on to question 13, I want to make sure that we get our next sessions locked in. I do not have these time slots available this coming week. Um, are there. Can I ask which of the following times of day is best for you? Do you do best with 3 p.m. Eastern, 7 p.m. Eastern, or 8 p.m. Eastern? I'd really be looking to fill out those latter two if those are an option for you at all. On any day of the week for the 7 and 8 p.m. For the 3 p.m. EST, I only have Monday, Wednesday, Friday. Um, I would love to offer our normal time, but tragically, a group class, which is scheduled that I have no control over, is taking that time. Sure. I might have to push a little bit out of my comfort zone with a different student. We will see. It'll be an exciting time for everyone involved. I think it will probably be okay. So Wednesday, Friday at 3 Eastern. It looks like Tuesday, Thursday, 4 p.m. is going to remain taken for a little while, but Monday, Wednesday, Friday, 4 p.m. will begin to open up from the week after that on. Excuse me. Okay, I need to schedule that. Um, 793 711 3. All right, I'm going to think about this very carefully because my brain is fried enough that it's very easy for me to press the wrong things. Okay. Ow. Are you sure that you don't know anyone who's capable of amputating throats? Damn it. You're sure that none of your classmates are secretly serial killers? With a pen? You're not sure? Oh. Are you friends with any mountain lions? Damn. That's really unfortunate. Like, I'm willing to work with an amateur at this point, right? I don't even need a professional neck amputationist. All right. Anyways, let's take a look at question 13. Yeah. Do note this is a support question, but we are weakening a claim. Mm-hmm. Mm-hmm. Excuse me. And you are correct to do so. You are 100% correct that that is the only one that calls out a difference between the host star and its planets. And that's really the only thing that can weaken this claim. Your thought process in the here and now was super lovely. D and A are completely unrelated to the claim. B is talking about similarities or differences, but it's between stars and not stars and planets, so it doesn't logically work. Only C is showing off a difference here. Phenomenal job. Uh, that was also a fairly timely process through it. That was nice and clean. 14 is another support question. Um, I don't know that we'll have quite enough time for this one. Do you want to cover this one here and now, or do you want to wrap things up with a dumb fact of some variety today? Okay. I would like to have enough time for 14 since it is a noticeable step up in terms of difficulty. So let me copy paste this in here first. Double checking. And then have you been finding the SAT question bank material that I provided you with? Has that been going okay? Um, if you keep going at your current clip, I think that you'll probably end up bullying through all of that eventually as well. When you do, let me know. I'm going to point you at another free resource. And if we really, really begin to run low on things, I'll begin to pull in some content for my personal business as well. Excuse me. All right. Um, Speaking of which, I've also got a student on my personal business who, like you, is burning through a shocking amount of material. Um, I'm very concerned about getting him the amount of material that he's hoping to do, since he's only working on the reading side of things. It's very challenging. It takes so much time to write reading content, man. Um, let's talk about a dumb fact. Let's talk about a dumb fact related to reading. Have we talked about notional agreement before? This is something that can come up on the ACT, but I've not seen it come up on the SAT. There are two forms of verb agreement other than subject-verb agreement. One of them is notional agreement, the other is proximity agreement. For this sentence, which one would you use? But isn't $10 plural? And we're supposed to use are with plural subjects, right? Yes. And that's notional agreement. Even if our subject is plural, if we think of it as one thing, we use a singular noun. Would you use is or are for this sentence? Yeah, but the subject is there, and there isn't singular or plural. So why are we using is instead of are? This is something called proximity agreement. If your subject is neither singular nor plural, you agree with the closest noun instead. In this case, a cat or many dogs. All right, I'm going to have to leave you with that. I'm going to limp through writing your email, and then I'm going to get to take my very brief break before my next class. Excuse me. Gosh, I really wish that muting worked okay on Adobe right now so that you didn't have to hear all of my coughing, but every time I mute, it does this. So you disappearing want to from the fire set. It does. Does it? When I connected my microphone, that's really, like when I do this, it sounds different. Oh, that's not good. I think that's probably something that Adobe is having. All right, I'm gonna have to let you go though.